In this session, we're going to see about relations. A relation is a mapping from one set, usually a set of inputs, to another set, which it should make sense, are outputs. Relations can be represented in four ways. They are using an equation, like x squared plus y squared equals 25, or a graph, such as this circle, a set map that indicates which inputs go to which outputs, or a list of ordered pairs, which basically has the same information that the set map does A1, A2, and B3 in this case. If we consider the domain of the relation to be the set of first coordinates, which we have here in the set map as inputs, and the range as second coordinates, which we have here in the set map listed as outputs, then the domain of the relation that's given in the set map and the ordered pairs is the set of first coordinates A, B, and the range is the set of second coordinates, in this case 1, 2, 3. In terms of a graph, the domain would be the set of first coordinates, or in this case x coordinates, and the range would be the set of second coordinates, or in this case y coordinates. We move on to our first example. Find the domain and range of the relation y equals the square root of x minus 4. We want to consider this in the context of real numbers, and as such, we don't want any imaginary numbers, and so, as you may recall, the radicand of a square root cannot be negative if we are to stay in the real numbers. So, for the domain, we want to consider values such that x minus 4 is greater than or equal to 0. And if that's going to be the case, then of course x must be greater than or equal to 4, and we can express the domain in set notation by simply writing down the set of x such that x is greater than or equal to 4. If we wanted to, we could write this in interval notation with a bracket at 4 and then to infinity. Since the range consists of y coordinates, and they are never going to be negative in this case, we can say that the range is going to be where y is greater than or equal to 0. And in set notation, we're looking at the set of y such that y is greater than or equal to 0. Notice that the domain is going to be in terms of x, and the range is going to be in terms of y. Alternatively, in interval notation, we would say square bracket 0 to infinity, and one thing you get out of interval notation is you don't have to straighten out x versus y. But we can circle that answer and move on to the next example, which is find the domain and range of the relation x equals the negative of the absolute value of y. Well, in this case, it's probably easier to start thinking about the range, and the range here, remember that the range is going to be the set of y values, and when we see that this y is in an absolute value, it indicates that we can put anything in there. So the range is actually going to be all real numbers. The domain is going to be the set of x values, and since x is the negative of the absolute value of y, and the absolute value itself will never be negative, these x values will never be positive. And so the domain is going to be in interval notation negative infinity to 0 with the bracket at 0. Or if you wanted to, we can give this in set notation. Now the domain is going to be the set of x such that x is less than or equal to 0, and the range being y values is going to be the set of y such that y is an element of the real numbers, which doesn't seem to be too much better than just using the... For our next example, we're looking at find the domain and range of the relation given by the graph, which is an ellipse, and the domain is going to be the set of x values associated with which we have graph. And the range is the set of y values, again, for which we have graph. And so it's, if we think of this just as all the x coordinates together, then it might make a little bit of sense that In this case, the domain is the set from -2 to 6. And we're using square brackets because we do actually have a point that has a first coordinate of -2, and we have a point that has an x-coordinate of 6. For the range, we're looking at the y values, and all of the y values for which there is graph associated. We're looking at the interval from 1 to 3. We could give this in a set notation as well, in which case the domain would be the set of x such that x is between -2 and 6, and the range would be the set of y such that y is between 1 and 3. Either of these would be fine with me. Next, we're asked to sketch a graph of a relation and give the domain and range, the relation in question being y equals -1/2 x squared plus 2. And if we don't have a ready picture of what this ought to look like in our heads, then a good way to figure it out is to crank out values using an xy table. And I think good values would be values for which the argument, in this case x squared, would equal 0. And then values close to that input. And so I'm going to use the values of, say, -2, -1, 0, 1, and 2. And using the order of operations, we get outputs of 0, 3/2, 2, 3/2, and 0. And it looks like I might want just a bit more information. So I'm going to throw in -4 and 4 and get outputs of -6 for both of those. Now, just for good form, I'm going to label my axes x and y. And then might be a good idea to indicate my scale. So I'll mark up to 5 on the y-axis, and then I'll do the same for the x-axis, and then throw in the negative direction as well. And now I can just, I suppose, plot my points. Again, I'm going to start with 0, 2 for no concrete reason, just that I happen to know it's in the middle. And then we can plot the rest of the points that we have. And then connect those dots with a nice smooth curve. Wish me luck. And what we end up with is a parabola. Well, that's great, but we were supposed to give the domain and range after sketching the graph. And again, the domain is going to be the set of x values for which there is graph. These arrows indicate that this graph continues its trend to infinity, forever. So the values, what are the inputs that we can put in? What are we allowed to use as input values for this relation? The answer is going to be all real numbers. And so here we have that the domain is all real numbers, and for the range, we're again looking at the set of y values, outputs that this will take on. And it looks to me like all the negative values, not up to 2, is the answer there. And so in interval notation, we're going to say from -infinity to 2 with a square bracket at 2. And that would be good enough for me. We could also use set notation. It's your preference. And finally, same instructions. Sketch the graph of the relation, give the domain and range, and in this case the relation is x equals the square root of y minus 3. We're going to do the same thing we did before, that is use an xy table, but we're going to kind of switch things around a little bit because since this is the square root of y minus 3, it seems to me that it would be a little easier to put perfect square numbers in place of y and then figure out what x values correspond to that. And so yeah, okay, the inputs become outputs. Don't get too hung up on that. We're really most concerned with thinking about that the domain is x values, the range is y values. And when we put all this together, we can come up with a graph. So the associated x values for 0, 1, 4, and 9 are -3, -2, -1, and 0. So I think it would be judicious for me to mark some things here. So I've labeled my x and y axes and put some values on my little hash marks here. And plotting my points, -3, 0, -2, 1, -1, 4, and then 0, 9 is way up here, I suppose. And we end up with a graph that looks kind of like that. Looks like half of a parabola, kind of. In fact, it is. Once again, the domain is the set of x values for which we have graph. This arrow indicates that it goes on forever. The range is the set of y values for which we have graph. And so we can say that the domain is the, we'll use set notation just to mix it up, the set of x values, the set of x such that x is greater than or equal to -3, and the range is the set of y such that y is greater than or equal to 0, which kind of makes sense. We wouldn't be able to put a negative value in place of y and get a real number, and so we can kind of think of it in those terms. In any case, there we are.